Right, so women played a role in the scientific revolution as well. Some were moral voices telling us to be careful of tampering with nature. Others gave us even more knowledge and assisted. Okay? So you look at Margaret Cavendish. Margaret Cavendish was a female author and philosopher, and she warned science that science should not mess with Mother Nature too much. That if you go too far, Mother Nature might mess back. That science needs to learn boundaries and limits and even use its science with morals and caution. This becomes a major theme in science, and it still is. How far should science go? When is it okay to perform an experiment? When is it not okay? When is it morally questionable? What's the purpose of science itself? You see this in the classic story Frankenstein. Dr. Frankenstein went too far, tried to play God, and created a monster that then destroyed his very life. And so Margaret Cavendish, she talked about this before, Frankenstein came out, before any of that. And this question, it still applies today. Today we would ask questions like, when is it okay to mess with someone's genes? When is it okay to alter DNA? Is it ever going to be okay to clone a person? If so, under what circumstances? Right? These are huge questions that science needs to ask. And if Cavendish was still alive today, she would be telling us to proceed very carefully. Now, some women actually gave us even more science, more data, like Maria Winkelmann. She was an astronomer, and there are a lot of women involved in astronomy. Because many of them would assist their husbands who were also astronomers, right? Astronomers often needed assistance late at night, and it just made sense for these male astronomers to train their wives to be their assistants. And Maria Winkelmann is one of those examples, and she goes on to actually surpass her husband, and she herself discovers a comet, kind of gave her a claim to fame. Interestingly enough, when Maria Winkelmann applied for a professorship, she wanted to be a professor at a university, that university told her no, and their reason was simple. They told her no because she was a woman. The university argued that even if they hired her, no males, which all their students were males, no males would come to her class and sit underneath the authority of a woman. Right? But each of these women, Margaret Cavendish, Maria Winkelmann, Mary Wollstonecraft, who we'll study later on in the chapter, each one is chipping away at this idea that women can't learn. Right? They're chipping away at this male-dominated society, baby step by baby step. So now we come to a very important guy named Rene Descartes. That's not Descartes, it's Descartes. He was a mathematician, he was a philosopher, he was a soldier, he was a mercenary, he was possibly a spy. Pretty interesting guy. And what Descartes wanted to know is, what can we know for sure? Because science had kind of turned upside down our worldview. We were no longer the center of the universe, for instance. We figured out that the Earth is hurtling through space around the sun, spinning on its axis, right? And for centuries, we held the exact opposite. So Descartes wanted to know for sure, what can we actually know? So he started off by starting from scratch. He started off by doubting everything. He said, if I'm going to figure out what we can know for sure, I'm going to assume that everything is false. I'm going to doubt everything. Then I'll add back to my knowledge bit by bit. So Descartes was alone one night, and he's thinking about doubting everything, and he had a light bulb moment. He had an aha moment. He had a eureka moment, in which he said, "But I immediately became aware that while I was thus disposed to think that all was false, it was absolutely necessary that I who thus thought should be something. And noting that this truth, I think therefore am, was so steadfast and so assured." Basically, he realized, since I'm sitting here doubting whether or not I'm real, I have to be real. Because if I wasn't real, I couldn't doubt whether or not I was real. So the very fact that I'm doubting whether or not I'm real proves that I'm real. Since I am thinking about not being real, I have to be real. I think, therefore I am. Right? Then he goes on to argue that he knows his mind is real. See, I think, therefore I am. But he could still doubt his physical existence. So that must mean the mind and body, or mind and matter, physical stuff, are two very separate things, which is actually a pretty cool idea, because then he went on to say, all right, if the mind is basically separate from physical matter, the mind can rationally, logically, without emotion, analyze matter. And he is called the father of rationalism, the idea that reason is the source of all knowledge, not faith, not tradition, not instincts, not your gut, right? Not your heart, right? But logic and reason. He probably wouldn't like that title, actually, because he was a devout Christian himself. Now, he believed in the importance of rationalism and of logic, but like Newton, he believed logic was a sign that pointed to a larger deity. Right? Of course, the universe made sense because it was designed by a creator. So he probably wouldn't dig the idea that some people use his hyper rationalism to try to destroy religion. But either way, this rationalism, this becomes amazingly important in European thought. The idea that you should approach life and all decisions with reason, logic, right? Not necessarily emotions. And our last guy in section 1, Sir Francis Bacon, who was not a scientist himself. He was more of a philosopher. You've probably heard of him before because you've probably heard of the scientific method, a very rational method that science still uses to discover truth. So you come up with a theory, then you test the theory. See, this is the difference between modern science and what was used to be called natural philosophy back in the days in ancient Greece. They would just develop a theory, and if it seemed to make sense, they would go with it. Right? The scientific method says, well, once you create your theory, you then have to test your theory through a series of controlled experiments. Then you take the data you get from those experiments, you analyze the data to see if your theory was right. If your theory was right, woohoo. If your theory was wrong, well, then you create a new theory, and then you start the process all over again. And what's neat about science is even if you come up with a theory and the experiment does not support your theory, it's not a failure. You simply know what the truth is not, right? You're still one step closer to the truth because you have eliminated what the truth isn't, which is pretty nifty, right? And so this is inductive reasoning, right? You're going to look at a very specific example and then try to apply it to the general, very broad sense. So, for instance, a dumb example is if I drop a pencil out of my hand, it falls to the ground. That's very particular. That particular pencil fell. Right? And then maybe I grab a handful of pencils and I let them go, and they all fall to the ground. Right? That's less particular. That applies to all those pencils. So then eventually I could think, well, you know what? I bet if I drop any pencil out of my hand, it falls to the ground, right? That's even less particular. And then I could eventually get to the point where I say, if I let go of anything out of my hand, it is going to fall to the ground. That is very general. That is not particular at all. So we've moved from the particular, one singular pencil, to the very general. If I let go of anything, right, it is going to fall out of the ground. So Sir Francis Bacon, like I said, was a philosopher, not a scientist. So he started to ask, all right, what's the point of all this? All right, so what's the point of discovering things about the universe, right? Why are we even doing this? What's the point of science? And he says it's to serve humanity, that we learn so we can improve the lives of humanity, that science should serve the purpose of not just knowing just to know, but to know things to make our lives better, through medicine, for instance, to make our lives more orderly and rational and logical, more humane, better, right? And just have a higher quality. So science should always serve the purpose of serving humanity.